Hello friends, in this video we will make a simple implementation program for insertion and deletion in a linked list. At the end of the linked list, that means after the null, the new element will be inserted. So let us begin. In the beginning we will include the stdio file and we will also include the malloc.h for dynamic memory allocation. Then we will define the node structure for our linked list. So we have struct node. In this we have a data part. This data part can be composite data also consisting of multiple fields. But for simplicity I am taking a single integer element in the data part. Then the struct node type of pointer next, which will point to the next element in the linked list. If you do not know what is a linked list and how insertion and deletion at beginning are done, then I have other videos recorded on this topic which you can refer, and I will give the link in the description box. Now after the structure has been defined, we will define the pointer start, which will contain the link to the first element in the linked list. We are making it global so that we are able to access it all over the program. Now first of all, we will make the insert function. So insert at end, and we will receive the item to be inserted as an argument. And within this insert, first of all, we need to create the new node. So struct node star temp, temporary node, and using malloc, we will take the memory from the system. So node star and malloc size of, and in this we will pass struct node so that the memory that is allocated will be of this size, and then we typecast it. Then in the temp data we will put the item which we have passed. So we will place our data on the new node, and now we want to insert at the end, so definitely the temp next will be null. So we can put it here, temp next is equal to null. Now there are multiple cases. If the start is empty, the start is null and no element has been added to the linked list, in that case what we will do is we will simply say start is equal to temp. We will assign the new node to start itself. Otherwise, what we are going to do is we will reach the end of the start and we will reach the end of the list, and there we will make the insertion. So for this operation we will need another pointer. So I am taking the struct node type of pointer p, and I am initializing it with start. Now in this pointer p, what we are going to do is we will take a loop, while p is not equal to null. So we will check while p ka next is not equal to null, we will move in the loop. Okay, so many brackets have appeared. Okay. So, and within this loop we will just say p is equal to p next. So we are updating the pointer till the point we reach where the list end is there, and when we come out of this loop, p will contain the pointer where we can make an insertion for the new element. So what we will say is p next is null. So we will modify this value, p next is equal to temp, and this will simply make the insertion, and we can print a friendly message for the user. Printf the item is inserted, right? So put a semicolon here, and this is the end of the function, and the element has been inserted. So you can save this using Control S. Now we will make the function for delete. So we have delete at end in the linked list. It will not receive any arguments because we're deleting a value. The value that you're deleting, you can return that value to the calling function so that we know what has been deleted from the linked list. So again, we will take a struct type of pointer, temp. In this, we will copy the node that is to be deleted, and then we will free that memory. So first of all, struct node temp variable is taken. Then we need a struct node pointer p, which will be used for iterating. So we'll initialize it with start. Now we'll check if start is equal to null. If there are no elements in the linked list, we'll print the message no elements in list, right? Because we cannot delete from an empty list. And then else if we'll say start next is equal to null. That means only one element is there in the linked list. In that case, simply what we have to do is we have to copy that element into the temp, and we will set the start is equal to null because there is only one element in the linked list. So simply we will remove it from the list, and so we'll print a message to the user that %d is deleted from list, and we will print the number. So we'll say temp data, and then we'll put a semicolon here, and we will simply free the temp because it is a dynamically allocated memory. So we have to explicitly free the memory. So this is the case when only one element is there. Now the regular case where there are more than one elements in the linked list, and we want to delete the element in the end. So we have initialized the pointer p to start already. So we'll say while p ka next two times we will use p next is not equal to null. We will iterate in the list. If there are more than two elements, this will work perfectly. So we'll just set p is equal to next till the time the pointer to p points to an element, which in turn points to an element which has next is null. And when we come out, we'll simply say temp is equal to p ka next, and p ka next is equal to null because that is the place we want to delete the element. And then we'll print this message again that this has been deleted from the linked list. And we will free the temp. Now we will call these function in main. So let me define the main function, and in the main I will simply call insert at end and say I want to insert 10. Then again I make a call to the same function. So I insert 10, then 20, then 30, and then 40, and then I delete at end, and I delete a value. I have not defined traverse, so let us quickly define the traverse function. So in traverse, what we are going to do is we will define a struct node type of pointer p. We will initialize it with start, and we'll say simply while loop is there, while p is not equal to null, and we will printf %d space on both sides, and we will print p ka data, and we will simply set p is equal to p ka next. So this will take us through the list. So we can put a friendly message printf /n elements in list are put a /n here, and like this we can print the linked list, and we will put a traverse call here so that we see what has been inserted, and then we put a traverse call here to see what has been deleted, right? So let us compile this code. Let us see if there are errors. So compile. Okay, there are errors. Invalid reprocessing directive. Okay, we have to put / for comments. So save it again, and I compile it once again. And okay, here we have put a bracket by mistake. Okay, let us compile again. Okay, it has come with no error. So let us run the code. So when we run the code, the item is inserted. The item is inserted for 10, 20, 30, 40. We have got the item is inserted 4 times. Then the elements in the list are 10, 20, 30, 40. And then 40 is deleted from the list. Then the elements in the list are 10, 20, 30. So we can see here we are able to perform the insertions and the deletions at the end of the linked list. If you like my channel, subscribe to it, share it with your friends, and keep looking forward for more such videos on programming and computer science. Thank you very much.